In the context of what businesses do, that there is a large adoption of Kubernetes as a platform to build, run, and manage your core applications. That is growing, and from the perspective of how we think about this perimeter, the identity is the foundation for everything that has to do with how somebody gets access to something, how you identify something, how you issue those identity to those workloads, and how you manage it. So all of those things are growing exponentially. When we think about identity for workloads, it's very easy to say, what is a workload? What does it mean? And how do you think about an identity for a workload? One of the aspects of a workload is the fact that it is some sort of a software. It's an application, it's a service, it's a container, whatever that might be, essentially has its own identity that can be derived purely based on where it is running. That's the genesis of identity that we talk about. When we say we want to issue an identity to a workload, we want that workload to have the context of everything, the identity having the context of everything that is associated with workload. When we talk about progressive security teams, they think about building effective governance and controls around how these identities are essentially issued, managed at scale for specifically workloads that run in cloud-native environments. So these are some of the reasons why we talk about the perimeter, and when somebody says the perimeter is gone, so why is it gone? How is it gone? We don't have any of those things that determines where somebody deploys a workload. You have multi-cloud, you have multiple hypervisors, you run it in data center, you run it in virtual machines. There are workloads everywhere, and applications are deployed and running everywhere. So that aspect of a fixed network-based policy that allows how somebody gets in just doesn't work. So which is why we think about identity as that foundation for that. There are challenges around what it means to think about this at scale. So I want to spend some time having Akbar talk about their own specific challenges and how they see it, what they thought about identity specifically from the perspective of NFCU, what they went about thinking about challenges and how they went about solving them and what it means for them.
Thank you, Sitaram. So at Navy Federal, we started our cloud and Kubernetes journey about 5 years ago as part of our digital transformation initiative. And now it's getting momentum, right? The adoption of cloud and cloud-native tech. And I think I speak for all of us, right? In our environments, we'll see multi-cloud Kubernetes, Azure, Tanzu, Oracle, Amazon, Google, what have you. But in addition to that, right, we have our internal platforms. We probably have service mesh that we're looking at. And then we have our dedicated on-prem infrastructure, right? And on these, right, there are these custom apps that are running that we provision search to, hosted services. Could be a vendor white label solution that we provide a cert for, API endpoints, databases, virtual machines, what have you, right? But the key thing is authentication, right? How do you get, for the last mile to install the cert via automation at that endpoint, right? How do you get authentication working? So these are some of the challenges that we have to think through, right? How are we going to get consistent authentication, across clouds, in your Kubernetes environments, both on-prem and the cloud? How do we use a standards-based authentication, ideally with identity federation? How do we remove the overhead? How do we train our customers to move away from long-lived creds, right? Be it a service account, be it a RSA key pair that they're using, or a long-lived cert, what have you. These are the challenges that we as cert teams need to grapple with in our organizations. In our environment, right, we've understood that a workload can transcend your cloud boundaries. So you could have a workload in the cloud that's accessing an API on-prem, right? And so how do you manage the identity context, right? Because we know that identity at present is distinct and disparate between your cloud and on-premise environments, right? In your cloud, you might have a service principal cert. On-prem, you might have a service account, what have you. Then there's an addition complexity around secret sprawl, right? If every team in your org is kind of independent and siloed, they can have their own vaults, and they're managing their own creds, and this adds to the issue here, right, around governance. And how do you police like overprivileged workloads? And if everybody has their own trust domain, right, then you now have multiple secret zeros, right? That first cred that they use to access their secrets environment. So these are the challenges that we are thinking through and that need to be thought through by all of us.
So this was something over a period of time. So we've been working with Navy Federal for about a year now, especially in their journey as they have been adopting cloud-native technologies, and the security team working very closely with various app teams that are deploying and running Kubernetes at scale. And as we started thinking about effective governance purely in the context of managing workload identities, we think about it, one, the validity. So, the validity of the certificates and all the things around Google 90-day, everything that, we talk about certificates and the fact that they should be not have a duration that is very long, that becomes very difficult to manage. So reducing the validity of all of the X59 certificates is one aspect of effective governance. We'll talk about how to do it. We talked about, using a standards-based approach. Even if you don't know a lot about the word spiffy there, you probably heard it in passing or in some context somewhere, or read about it purely in the context of security. That is very critical, especially in the context of what we talk about securing and providing that mutual TLS in environments that are cloud native, service meshes which naturally adopt spiffy as a compliant way to issue and manage identities. So you are already seeing a lot of spiffy in spite of not seeing it a lot, because it's inherently built into many of the things that are deployed and running in your organization. So we're talking about using that as a standards-based mechanism to issue and manage identities at scale, allowing you to easily federate to multiple systems and also being able to manage it at scale. Decentralized PKI. We generally think about PKI infrastructure as the central component that runs in one place and provides service for the entire organization. That is typically not how things should be working, especially in a cloud-native environment. We want that to be decentralized, and we'll talk about a pattern on what that means specifically. Many of the native tooling that are used provide a way to do things with a self-signed CA. And we want to make sure that that is known earlier, you have the right kind of visibility, and you have the ability to mitigate it. It's too many secret zeros. This is obviously a challenge, as there are multiple teams, each one of them, as they think about their environment as their own trust domain, they are essentially responsible for managing their trust domain. Another team thinks exactly the same way. This is my trust domain, which means I have a trust boundary associated with it, so I'm going to manage everything. When you have 10, 20, 30 of those, you essentially have multiple trust domains, and each one of them essentially managing it as a silo, and everybody having their own secret zero to access it, which essentially obviously leads to a lot more challenges than managing it easily. When we talk about Kubernetes specifically, we see a lot of container instances that are running everywhere. But the way we think about it is, if you don't tie in and make the identity associated with the life cycle of that container, you will essentially deal with probably multiples of that 6.4 billion of identities. We don't want that. We look at it purely from saying, if a workload is born, we want to issue an identity to it, and if a workload is destroyed, all of the key material associated with that identity should be taken away and destroyed. So the life of an identity should essentially be managed as part of the life of the workload itself. That obviously means that the duration or the life of that certificate itself is reducing. Obviously, the lifecycle management should adopt to the modern behavior. The modern behavior being that there's a pipeline that automatically builds, deploys, and then at some point when a new version has to come, it destroys and redeploys it. So the identity should be associated with that life cycle. This picture is something that we are using as a way to represent how somebody manages their PKI today. You have a lot of different environments that are running everywhere. Multiple cloud environments, multiple hypervisors, data center, but you have that PKI which is serving everybody. The challenge is it does not scale for a cloud-native development in a modern world. It has risks associated with developer activity. We talked about how somebody would deploy an application and then just use a self-signed CA. Absolutely non-compliant from a PKI perspective. Where we want you to go is like this. We want you to be able to delegate and have that PKI supporting every aspect of your business autonomously, locally, with the ability to issue compliant identities for that application and that application only and nothing else. That is literally how we see decentralized PKI in action, being able to allow you to still manage it, still ensure that you have full visibility, still ensure that you have the ability to define and govern those policies, but allow developers to go much faster and allow developers to consume those identities locally without telling, you need to come to me over this network, take a net latency hit, or I may be down, but whatever the reason is, you can't have those things working, especially when people are going super fast in a cloud environment. So this is essentially how we see allowing you to be, one, obviously crypto agile and having the distributed issuance capabilities. And two, this allows you to ensure that every single developer workflows have the ability to consume a certificate much easily with the APIs that are there, that they are already using in the pipelines that they are already built, without having to reinvent anything, because you are providing that first-class service for them to be able to consume those certificates. So identities at scale become super simple, because when you have a model like this, it doesn't matter whether you want to issue an identity for 24 hours or 7 days or 1 hour or 2 minutes. You can support all of those use cases because there is no reason why you cannot support it when you have an issuer running locally there. We talk about distributed workload identity issuance, especially in the context of decentralized PKI, because as you can imagine, this eliminates all of those single points of failures. There is no single point at all, so you can't have a single point of failure. Whether you're deploying thousands of containers or millions of containers, it doesn't really matter, because you are essentially issuing an identity as part of the workflow of that deployment, and then also taking it away, right? We talk about tackling the secret zero problem. Long-lived credentials has been the biggest challenge for many of the organizations. We want to get rid of long-lived credentials. It shouldn't be there at all. Multiple workload processes always relying on some static API keys, overprivileged secret zero. So we talked about multiple trust domains, and each one of those trust domain having its own ability to manage its own secret zero. And each of those secret zero being overprivileged in a way where it can access all of the various different things within a vault or something. The risks, obviously, is attacks and also huge blast radius, because you have a lot of challenges as you sort of think about multiple secret zeros. Ephemeral identities, I did not use the word. When we talk about all of those things, when we say a workload is born, issue an identity as part of the life cycle of that workload, we're talking about issuing a just-in-time identity. That's exactly what it is. Just-in-time of what? Just-in-time of the time when a workload is born. That's what we're talking about. If the workload is destroyed, we want to get away or throw away and destroy all of the key material, because we want to make that identity highly ephemeral in a way where, think about the workloads are also highly ephemeral. Completely eliminate secret zero. If you talk to us or some of the teams, because we are CyberArk, we will tell eliminate secret zero, because you don't need it if you're using secrets management or secrets hub or Conjure. SPIFFE Spire, we're seeing a lot of adoption of SPIFFE, and also people trying to understand and see how Spire plays a role in that federated authentication mechanism. So those are some of the things that we're seeing as part of how we think about tackling the secret zero problem. What we really want is to be able to have those PKI infrastructures as locally as close as possible to the workload, which will allow you to deal with infinite number of requests from that application, and that application being served by an identity that is locally managed, locally issued, governed centrally, policy controlled, managed centrally, with either with the PKI that you have, with zero-touch PKI or HSM-backed key. All of those things are still something that you will have full control over. That's all.
Thank you all.